Thank you very much for tuning in. I am your host of Swagelok Southeast Texas Talks, Buster Caballero. My co-host, Logan Boatwright, is out for today. He will be back next week when we're going to have another awesome episode. Our guest today is Trey Sinkfield, professional engineer with Swagelok Southeast Texas and a member of our field engineering team. We're going to talk today about how you can effectively troubleshoot a fluid system, get a greater return at lower cost, and why you should be asking for more than just high quality components from Swagelok. So welcome to the show, Trey. Welcome. Thanks for joining us, man.
Hey, thanks for having me.
So we may be having a little bit of lag in here. We are dealing with technology, different areas, and also, Trey, you and I both have 3 kids, so there is the chance that we will hear screaming and crying in the background also, right?
Oh yeah, like I said, it's only a matter of time before the storm hits.
That's right. That's right. So, Trey, to start off, man, we've been working together for a while, but for those tuning in, give us your origin story, your superhero story, what your background for us.
Oh yeah, I love that Avengers reference there. So I'm originally from San Antonio, and I graduated from UTSA with a mechanical engineering degree, and specialized in thermal fluids. And when I got out of school, or I was about to get out of school, I said I didn't want to get into oil and gas. That's just where everybody's going. I'm not going to do that. I want to do something different. And I ended up getting my first position with the Department of Energy. And interview was in Pittsburgh, and somehow they ended up in Oregon, Albany, Oregon, which is about an hour south of Portland, at a research facility for different energy applications. So consequently, I ended up getting a lot of experience with setting up lab systems, working with PhDs who were mainly concerned with the principles of testing the science, but not really concerned about doing it safely. So I got a lot of experience with fluid systems under 2-inch to either model a reactor system, or set up a pilot a process, but scaled down. So therefore, I got a lot of experience with the Swagelok product, designing and sizing due to flow rates, orifice sizing, regulator sizing, and pressure relief calculations with reports. As I was getting that experience, I made sure to set myself up to get a professional engineering license. And then after about 5 years, I heard of this thing that they were calling assembly solutions with Swagelok. So I inquired a couple of times about having a couple of my systems built by my Swagelok vendor. And then they approached me about, what do you think about helping us develop this program? And I said yes, but not in Oregon. So I was like, I want to go back to Texas as close as possible to San Antonio. There's a really great opportunity here in Houston, and I ended up in oil and gas.
Gotcha.
It got me. But I've been really happy in this industry because it's working with Swagelok. It's not just one site, or which I was at before, one site where I was able to work with a lot of different applications. But now within oil and gas, we get to go around and help different sites and different kinds of facilities. So just because it's oil and gas doesn't mean it's not interesting. There's a ton of applications that kind of pull from my experience before, and some that were brand new to me as I entered.
Yeah, that's one of the things is God, we expand everywhere. It's not oil and gas. It's, we talked about this on the last episode. It's pulp and paper. It's technology. It's all over the place. Aerospace. I mean, we go from the bottom of the ocean floor all the way up to outer space. So Trey,
Oh,
with everything,
definitely. And there's it's what's fun is that there's businesses behind all of these. So I found a little bit more purpose, and now I'm in school again at Rice University at the college, working on my MBA at the Jones School.
nice. That's great,
So
man. Oh,
thanks.
so Trey, and I know we're dealing with a little bit of lag right here now. So nah, it's just something we got to deal with. As always, give us a challenge and we'll face it. So how have you been doing things differently with the current environment? Not being able to get on site for some people, maybe having to meet virtually. How did things change for you in your role?
Well, I just didn't want to accept that we can't interact with our customer. Before this whole thing started, a lot of the uh, um, interactions that we've had started more virtual, and get me on site, and it was a very small time frame, and there's a lot of different other appointments that day, and we just came up with, you know what, why doesn't he just go on site, sit with the customer, and we connect via a virtual chat. So we were able to share screens, and I was able to look at their P&ID, and we troubleshooted their system right there because they had a three-way valve that was in the wrong orientation. So they thought that the system was doing one thing, and it really wasn't. It wasn't venting some quick connect couplings, and they were
Okay.
having some failures there. So we troubleshooted, and then we're able to quote off of that. So with this challenge, or at this time, we kind of doubled down on that. Say, why don't we do more of that now? And it's even better because more people are more available because they aren't having to drive to work.
Right. They aren't getting
So they
pulled
have
out
just
of.
maybe an hour and a half more. Exactly. Yeah,
Yeah.
they have about an hour and a half more per day to have a proactive conversation.
Right. And I think that's something we always see is that we could be in a meeting and somebody will come in and be like, we need you over here, or we need you there. Or it really gives the attention needed for what we're trying to accomplish out in the field. So with that, so when you and I started about the same time. You were a few years, maybe a year or two behind me on that side. And at the time, our assembly solutions, was once again just starting. I remember them saying like, "Hey, we're hiring another engineer," and it's like, "Whoa, that's pretty big for us at the time." We've got CAD designers now. We've got another engineer. Uh, so how has it started, or how has our assembly solutions evolved since you started to where we are now? Because right now we are rocking and rolling with our assembly solution. So how's that evolved for you in your role? I can't.
State of, as you probably remember, that we would have a celebration when we put a regulator together, and if there was a system, with a customer to say, uh, and then we started getting into situations to where I know what I want, but I don't know about the sizing of this regulator and these valves need to be, or do I actually need to have tubing? So we had to start helping them make those and then build it. And then we go from there to us being approached with, this is just my issue. What system do I need, or what do I need in order to solve this issue? So it could be a product, it could be a system, a whole gamut of things. So it goes from us, just tell us what you want and we'll build it, to here's a full-fledged design, and this is how we can build it. but what are your preferences? That's where we are right now. And then moving into, I know these are your preferences on these past 10 orders. Why don't we try to standardize on how you like to have these regulator assemblies or whatever this is. And then we'll make a part numbering system for you so that the next time you order it, we already have all of these features and all of your preferences baked into it. Now let's just focus on what's actually different about this other case or this specific case. So we do that on a global scale or a local scale. If there's a standard that a company has, we'll work with their corporate office or whatever office is deemed necessary to figure out what they like to roll out globally, and then have and to turn it into a global effort. We'll have uh, Australia and Europe, so that the meeting that we're having in Houston doesn't just get rolled out across the board. It's something that everybody owns at that company across the board.
So, Trey, let me ask you this. When something like that happens, our customers or our partners come to us and say, Trey, we want to do this project. Here's what we're trying to accomplish. And it's something that we have never done before. It's a new challenge for us. How do you go about facing that challenge as well as our capabilities growing?
Face it head on, Buster. Face
That's
it head on,
right.
things that I already have. I really didn't, and that's honestly what charges me up, and what keeps us going here is that we love those new challenges, and we love seeing how some things that we have done before do apply, and then it might apply differently or don't apply at all. And then you focus on just what's there, what do they have, and then what's their commercial situation. So those two things will lead you to what are the things in between that we need to gain. Is it expertise? Are there parts that we don't have already been identified by another Swagelok distributor? So if it's a temperature, for example, if it's a temperature control issue, I'm probably going to ask Swagelok Canada of what they do for that specific issue, because heat transfer is a big deal up there because it's always cold. There's different places that we can reach for the expertise within our organization and within the customer's organization. If they have a similar site that's somewhere else, we work through our Swagelok organization to figure out what they've done to solve that same issue at that site, so we could utilize that company's resources already, and then they don't have to spend the extra time and capital to come up with the same solution again just because it's in Houston.
Right. So that's one of the great things we have. Our advantages, our global network of distributors and the factory and our corporate offices and the engineers there, is that we're able to pull all these resources. And you and I have been in a situation where once we've gone to another distributor, they have a similar customer, we put them talking together, and now we have brand new connections that we've been able to help our customers create. So what I want to do now, Trey, is, when people are listening to this and they hear about, like our field engineering group and our field services and what we can do, I'd like to run through one of, recently you and I, we went on an analytical and instrumentation audit. And I'd like to walk through like what that looks like whenever we get in the field with our customers for one of these situations. So we had one where the customer came to us and said, "Hey, we're doing some work on our analyzer shelter. We're needing to run some new lines. We're needing to improve our system. It's a big scope, but we'd like for y'all to help us with this, with the parts." And for us, we said, well, let's take it one step further and let's look at the system as a whole. So we said let's do an AI audit or analytical instrumentation. We're going to go from the taps that you're running all the way to the analyzer house, everything in between. So what does that look like whenever we start? The main thing first, we have to understand the whole system, right? And what they're trying to do.
Yeah, and you said take a step forward, and first, in order to do that, you have to take one step back, and then go a few steps forward from there. And I'd just like to point out that you did a great job at that point, of taking a step back and asking the customer, okay, why do you want to do this? And in that particular case, it was they wanted a better a reaction from their analyzer to what's happening in their process. And the reason why is to make it safer. If they have an elevated oxygen level in their reactor, they need to make sure they react and give a signal back to the process to slow something down so they could calm it down, or else they'll have to shut down. If they shut down, of course, we know in this industry, you shut down for a day, you lose $1 million+ dollars. So we did is take a step back, figured out what was important to them, and then not only focused on what needed to be done in the system to allow that to happen, but what are the symptoms that they're experiencing, which we have to translate that, because a symptom sometimes is presented to us as the problem. So we look at those quote unquote problems and identify them as symptoms, and then isolate them as such, and then look at the entire system and understand what's causing that to happen. And usually where the problem is being told to us isn't actually in that area of the system.
Right, right.
So we go through and do look from all the way from the tap, the beginning of the system, and a very um, um, a very consistent way,
Right.
and and try to be very disciplined about how we go about doing it. And then those problems arise, or those issues in the root of those issues arise.
Yeah. And so for recently, we had to get on site for this one. Once we understood all that, we had to get on site. We had to obtain credentials to be on site, go through some training, checking in at the gate, safety videos. Then we had to meet with the safety guys. I had to shave my beard. I mean, it was all part of, before we're even in the field, we're putting a ton of work in ahead of time. And then once we get ready, we put the hard hats on, we're suited up, we've got our steel toes on, and we get in the field. One of the first things that I noticed that we did was we got to the first tap and started pulling out sketchbooks, and we're cataloging everything right there, and we're making sure that what is there, right?
Yeah, right. You cataloged everything that was there, and then we also had the leak detection guy with us, and also snooping down stuff, because although it's an analytical evaluation, we want to make sure the system is as safe as possible, and we're able to detect and quantify the number of leakage out of the system. So and beyond the field evaluation, looking from the tap all the way to the analyzer, um, we take that information and we make a report, which serves as a guide and a roadmap to what improvements they can make to the system at different cost brackets. So of course
Mhm.
we try to go after and urge them to go after the lower cost bracket, of course, that has the highest impact, because there's some things uh, that you can prevent happening, like pluggage in a fast loop filter. Maybe your flow is just below the limit of that of what that filter is designed for. So all you need to do is open a valve.
Right.
So that's something that's very inexpensive to do. And those are
That
the things that we're going to propose first. And then you get to the
right.
more fancy stuff that's more expensive.
I think the first two recommendations we had for the most recent one was uh, increase of flow and reduce of pressure, and that was just turning two knobs, and that was supposed to give the biggest benefit. And one of the other things about this that came with it was, we essentially recreate. I say we, but y'all really did the work. Y'all recreated the whole PID redrawing of the system, walking it down from the tap to the transmitter, and basically verifying that every component was in there, because we know that the PIDs sometimes don't always match what's in the field, right?
Right. So the challenge isn't the calculations or the analysis. A lot of times the challenge is getting the right data.
Right.
What is in the process? What is the analyzer giving us? Can we get a printout of that? And then is the PID that's given to us actually what's out there? And more times than not, it doesn't match. But um, it does help to shed light on how that years and what improvements were made to it in order to make it work for them. And that also sheds light on what issues that they had in the past and what things that are just patched up that could be causing other issues. So if a patch is causing an issue, look for why was that patch put there? Because if you take that patch off, now it's another issue that you've created or unleashed. So if you get to the root, solve the issue the right way, you solve the patch issues and the original issue as well.
Now, one of the benefits that I've seen with being in the field engineering team and AI audit, uh, is that we're actually being exposed to different areas of the facilities. And I know we're gonna plug oil and gas for a while. We're going to talk about just a plant facility, and even though we are wide reaching, we're very well known with the instrumentation group. We're very well known with the analyzer group. The thing that our field engineering group and you and your team and what you've done is that now we're being exposed to a lot of different areas. So for instance, now we're talking to the mechanical guys. Now we're talking to the rotating equipment group. Now we're talking to the maintenance team. We're talking to safety. We're talking to a lot of different areas of the facilities that before we may not have been that well known. How has that expanded what your capabilities in our field engineering group and our assembly solutions group is able to accomplish now that we have had this exposure to everyone?
Yeah, it's a good question, and it's one that can be answered a few different ways. And expand isn't the word I would use. It would be I would use the word magnified or amplified. It's amplified our abilities a little bit more, because some of the same things that we're doing for the other groups are the same things that those new groups that we're getting in front of need as well. Um, Fluids, they don't care what application they're in. It's the same science that applies to all of them. But the application just offers shortcuts and different ways to handle them. So you can parcel down those complicated calculations to a few products in a basket, or some spreadsheets or something like that. So we're able to come up with standardized offerings, like for API systems, gas distribution, and bulk gas supply in labs. We're standardizing those offerings. So now we're getting in front of slightly different groups, but from a slightly different flavor of products that we've already offered before in different industries. And it's rewarding, because you're getting to see the fruits of your labor in one area. Another group gets to gets the benefit from that without having to put in any front end work. We have stuff plated up for them already, and that feels really good.
Right. And it's amazing to see that growth where you could be talking to the analyzer guys on one section. You could be talking to the rotating equipment mechanical guys on their seal support panels. You could be talking to the engineers on their grab sample panels and how those are, and simplifying and improving a lot of these systems, where somebody might ask for a sample cylinder assembly from us. When we go a little further, it's because the sample panels that they're using maybe need a little bit more rework, some improvement to them. So that's just things that are coming out of us that our customers are asking us to do more, do more, do more, and we're finding that we have this capability to do more and do more and do more. So,
Right.
uh,
And
and
when they realize that they have us as another tool in the box, it it really helps our customers' capabilities as well, because we understand, and I've been there too, that engineers and technicians are put in a very difficult position a lot of times, where they have um, crazy expectations put on them to solve an issue with very little information. So they're
right,
able to just call us up sometimes if they have no other resource in front of them, and we're able to troubleshoot the system. Like figure out how much flow can they get out of this tube that's this long
yeah,
with these valves in it. And then narrow it down to, okay, the tube must not be deburred because I'm not seeing that flow anywhere close to it. So
right.
we're able to look inside the system without even being there.
Oh. So, Trey, we're getting to the end of our time here. So, I got a few closing questions I just want to ask for you right now. So, for our customers and for the people listening today, what's something that our customers can do, in your opinion, in the field when assessing a situation? If they come across like a problem or they're looking at a situation that's maybe not reading right, what can they do?
Well, first look at what they know. And of course, at the focal of it, if you have a failed part or system, uh, just don't focus too much on that. Just take notes, good notes on what's going wrong objectively. Um, just just figure out what truths are happening, and then how does the system look, and then and only then can you figure out how to get to the solution. You have to look at what's downstream that you want to happen, what's upstream that could be affecting how that piece is operating, because no system is isolated in these plants. It's all
Right,
interconnected.
right,
So for example, in in Kansas, when we were walking down an analytical system, we found some salts that were developing in an analytical line. Um, it wasn't the it wasn't the filter that we were looking at that was the issue. We had to go all the way upstream past the inlet of the analytical system, upstream to a catalyst bed, and with this that the catalyst had been changed in 10 years. And
yeah.
there's ammonia getting into the system and reacting with the filter element and causing salts to develop in there. So
That,
the problem wasn't even in the system that we're looking at.
oh man, that's a great piece of advice for our customers out there. And then the second one and the last one is, what is the most common problem you say we run into whenever we do get on site with a customer?
I would say one, finding the right P&IDs or the information that describes the system, and two, not rushing into it. A lot of times it's tempting to want to dive right in, um, but you have to look at uh, why are we doing this? You know, why is it important to the customer? What have they already tried? What what is actually in the line? Because if you just take their word for it on what the phase of the fluid is, and hey, it's a liquid, here's the pressure and temperature. But the more information you get, we can actually model the fluid and figure out what phase is it actually. You can objectively take the information that you have, but until you verify it, it can't be true for you if you're going to run an analysis on it. So that's our challenge, is not being tempted to jump the gun and solve a problem without knowing all of the variables.
Well, Trey, thank you so much. I appreciate you taking the time to come and talk to us today and go through all this great information. Really appreciate everything you do for us and for Swagelok as a whole. Man, I can't wait to get back out in the field with you. We got to come up with something good soon. So for everybody watching and tuning in, thank you so much. We really appreciate you taking the chance to watch our show or listen. If you do have a question or something has made you think of something that maybe you're facing right now in the field, do us a favor, reach out to us at Swagelok Southeast Texas. You can find us on the World Wide Web at sset.swagelok.com. You can find us on LinkedIn, Facebook, and Instagram. Just look up Swagelok Southeast Texas. We are all there, and follow us along so you can get more information like this. And once again, as always, tune in every Wednesday at 9 o'clock for these shows, and we're going to have a few more great guests coming on. And in the meantime, everybody be safe and have a good day. Trey, thanks again, bud.
Thanks, Buster.